Hey guys, so in this video we're going to be looking at summations, arithmetic series, and sigma notation. So first question, starting off, what does it mean to actually take the sum of a group of numbers? You're going to be seeing the word sum, summation, let's see if I can type or write, summation, sum, any of these words. What does it actually mean? Okay, anytime you see any of those words, I mentioned it before, but you're just adding them together. Summation, sum, any of those just means you're adding them all together. Okay? Well, in order not to have to write out each number with a plus sign in between them every time, so like we had to do whenever we did the mean, median, and mode, then mathematicians actually decided on an easier way to write summations. They decided to use the Greek letter sigma in order to actually represent a summation. So here's an example of what a summation looks like using the sigma notation. You see there's some numbers on there that you're not really sure what to do with. Well, the symbol sigma, that's how I'll write it whenever I write it out, indicates a sum, or adding things together. So the number at the bottom of the sigma is the lower bound, or the first number of the values that you're going to replace the variable with. And then the number on top is going to be the upper bound. Make sure this is fixed if it isn't already fixed on your PDF or your copy. Is going to be the last number that you replace, or the upper bound. Whatever comes after the actual sigma, so here we have this I, is the expression that represents each term in the sum, so each thing that we're actually adding together. So in order to determine the value of the sum, in order to figure out what this actually means, you're going to replace the variable, replace this I, in the expression, whatever expression you have over there, after the sigma. You're going to replace it with each number between the top and bottom numbers. So we're going to take this, and we're really just going to replace it with each number in between the number down here and the number up here. So let's look at an example. So if we look at this example, we're going to look at the top and bottom numbers. The lower bound, the bottom number down here, it says I is equal to 1. So we're going to start with 1. And the upper bound, one up here, is 5. So we're going to use these numbers, and we're just going to replace it. So we're going to take I with number 1. We're just going to put in a little parentheses down here. We're going to take this I with number 2. So we're just going to keep going from 1 all the way up until we get to the number on top, the number 5. We're going to replace this I here with number 3. We're going to replace this I here with number 4. And then lastly, we're going to replace this I here with number 5. So we just copy this over and over. We start at the number on the bottom, 1, and we keep going up until we hit the number on top, 5. And what this means, we're literally just going to replace the variable I with this number. So here we've got 1 instead of I. Here we're using a 2 instead of I. Here we're using a 3 instead of I. Here we're using a 4 instead of I. And then here we're using a 5 instead of I. We're just replacing the letter with the number that we wrote down here. So if we actually add all of these together, 1 plus 2 plus 3 plus 4 plus 5, we're going to get 15. So that's the answer to this. That's what this means. We're taking the numbers, whatever number you have from 1 to 5, and we're just adding them together. But that's not always exactly the case. So let's look at another example to make sure we understand what to actually do with the numbers. So sometimes the expression is more complex, so it's not just I, but you still just substitute values into the variable and evaluate at the end. So if we look at here, we have n squared, and we're going to do it from -3, and we're going to do that all the way up, adding 1 each time, up until 2. Okay, we have n squared for -2. Again, we add 1. We have n squared for -1. We have n squared for 0. n squared for 1, and again we're going all the way up to number 2 because that's what's on top. Then we have n squared for 2. Okay? And now again, we just replace n with these numbers. So we have negative 3, and then we have the square still. We have negative 2 squared. Okay, so we're just replacing the n with the number. All the way from negative 3 up to 2, because negative 3 is on bottom, negative 2, or positive 2 is on top. And we're just going to add all of our answers together. We have 0 squared, 1 squared, and 2 squared. If we actually do all of these out, so negative 3 squared, negative 3 times negative 3 is 9. Negative 2 squared, negative 2 times negative 2 is going to be a positive 4. Negative 1 squared is going to be a positive 1. 0 squared, 0. 1 squared is 1. 2 squared is 4. We just add all those numbers together. If we add 9 plus 4 plus 1 plus 0 plus 1 plus 4, we're going to get 19. And so that's going to be our answer for this one. So again, we're literally just going through, taking this, substituting in the numbers from this number all the way up to this number and adding together our answers. So let's try a couple more. I'm going to go over number 1, and I want you to try number 2. It's very similar. Okay? So again, we're just going to take n, and we're going to replace that with 0, 1, all the way up through 10 up here. So we're literally just going to replace it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Since it is just the variable, just n, we're just replacing it. Replacing n with 0, replacing n with 1, replacing n with 2. Okay? And then if we add all these up, we're going to get 55. You can type that in a calculator if you need to, or you can add it up in your head, however you want to do it. So I want you to try this one. Think, you're taking j, you're replacing it with the numbers from 0 to 5. Add them all together, see what you get. All right. So I'm going to go over 3, 4, and then I'm also going to go over numbers 6 and 7, and then you're going to be on your own for the rest of them. So, looking at number 3. We are taking this 3y. Okay, so we're taking this expression, and we're replacing the numbers, replacing y with the numbers from 0 to 6. So we're going to write 3y. We're going to replace y with 1. We're going to replace y with 2. We're going to replace y with 3. We're going to replace y with 4. We're going to replace y with 5. And then lastly, we're going to replace y with 6. Again, we stop at 6 because that's the number on top. We started at 0 because that's the number on bottom. And we're really just replacing y with these numbers. So 3 times 0. Instead of 3 times y, we have 3 times 1. Instead of 3 times y, we have 3 times 2, and so on. We're just replacing y with each number between our upper and lower bound and adding these numbers together. 3 times 0 is going to be 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. And then if we add all of these together, you're going to end up with 63, and that's your answer. So we take whatever our expression is, we replace the variable with every number in between the lower bound. So here's 0, top is 6, in the upper bound up here, okay? And then we add our answers together. So it doesn't always have to start at a positive number. I talked about that before, or there was an example earlier about it rather. So we're just looking at k, and we're going to do it from negative 5 all the way up to 5. So replacing k with negative 5, replacing it with negative 4, replacing it with negative 3, negative 2, negative 1, replacing it with 0, replacing it with 1, all the way up to 5, because that's the number on top. Replacing it with 2, 3, 4, we'll replace it with 5. So we're literally just replacing k And we're adding these numbers together. -5 plus -4, and I'll put parentheses around them to make it a little easier to see. Oops, I repeated -3. All the way up to 5, because that's our upper bound. So you can either type this in a calculator or do it in your head, but the way I did it, we have -5 and +5. Sorry. We have -4 plus 4, -3 plus 3, -2 plus 2, 1 plus 1, and then we just have 0. If we add all those together, we're just going to end up with 0. But again, you start at the number at the bottom, replace the k with that or whatever variable you have. You add 1, replace the k with it and add it together. You add 1, replace the k and add it together all the way until you get to the top number. So try number 5 on your own. We'll look at 6 and 7. So 6 has a little more complex of an expression on it, but it's the same concept. We're going to take this a squared plus a, and we're going to replace 2. Replace the a with 2. Okay, so we're going to start with 2, and we're going to go all the way to 5. We're going to take this a squared plus a, we're going to replace it with 3. Replace the a's with 3. We add this a squared plus a, we're going to replace the a's with 4. We have this a squared plus a, and we're going to replace this a's with 5, and we're going to stop there because 5 is our upper bound. So if we replace the a's with 2, we have 2 squared plus 2. Replace the a's with 2. We're going to replace the a's with 3. 3 squared plus 3. Make sure we have our plus signs in between. Replace them with 4. 4 squared plus 4. Then we're going to replace the variables with 5. 5 squared plus 5. Okay? And we're going to evaluate. Okay? So 2 squared is 4. Okay? We'll go ahead and square these out. You should know your squares, cubes, and primes by now. Okay? And I did not mean to keep the squared on this number here. So we'll fix that. That's just supposed to be 4 plus 2. Okay? So if we add these together, we get these. And then if we add all of those numbers together, we're going to end up with 68. So again, you take the expression, okay, whatever we have here, we replace the variable with each number in between from this number all the way up to this number, and we add our answers together. So if we look at number 7, we have n plus 1. We have n plus 1 over and over. We replace n with 0. We have n plus 1, and we replace n with 1. We have n plus 1, and then we replace n with 2. And I'm just putting the parentheses just to show what I'm doing. We have n plus 1, and we replace it with 3. And we're going to do this all the way up to 7. Okay, and we stop at 7 because that's the upper bound. We started at 0 because it's the lower bound. So if we replace these, 0 plus 1, 1 plus 1, we're just replacing the n with the number we're on. So 2 plus 1. If we simplify all these, okay, we get 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. And if we add those together, we're going to get 36. So to do the rest of these, again, you take whatever you've got here, you plug in the numbers from here to here, and you add them together just like we did each of these. So I want you to try the rest of them. Let me know if you have any issues, if you have any questions, and I hope you guys have a great day, and I'll see you later. Bye.